Good afternoon, I'm Inés Ibáñez, and I'm here to introduce you to the Global Change Ecology Lab. We do quite a bit of research projects, but I just want to give you a very broad view of our research program. So we are interested in how organisms are being affected by global change. And here when we think about global change, we think about four major drivers of change. And what is happening is that these drivers of change are creating novel environments, environments for which these organisms don't have any evolutionary history. So we can't really predict how are they going to respond. It's going to be very difficult for us to figure that out by using just little experiments. So what we need to do is to start building, try to get the building blocks all together to try to do any kind of forecasting of how these novel ecosystem will be affecting these organisms. So we have divided our research into three main areas. One has to do about novel species interactions. So as things are changing, species that were used to live together may not be living together. Then species that dependent on others may not find that codependent species. So we have a whole area of research on how these novel interactions may be affecting organisms. We also have some research on the idea that these organisms are also experiencing new landscapes. So as we are changing the land, not only for uses, but also through climate change, this is going to be affecting ecosystems and all the parts of those ecosystems. And then finally, we have this idea of novel climates. So maybe in the past, these species experiencing many of these climates, but what we have now are populations that are experiencing conditions that are novel. So we want to know what is going to be the immediate response, what is going to happen in the next 5 years, 10 years, 50 years. Are we going to see the same population dynamics, or this relatively novel climate is going to have a major effect in these organisms? What are the systems? With respect to experiments and observations, we work on forests, and we work here in Michigan all over from Ann Arbor all the way to Isle Royale. We work on all kinds of forests. We do all kinds of things with trees. We have quite a few of them. We also work on seedling recruitment because those are the new generations, and also the stages that are more affected by novel conditions. But with respect to our statistical work, we work all over. We go from the global level, where we work on predictions of invasive species risk, to the organismal individual level, like turtles at the George Reserve. The methods we use again all kinds of methods for experimental work and observations. We work in the field quite a bit. We use climate gradients, urban gradients, and also greenhouse experiments when we are more interested in mechanisms. But again, we do quite a bit of work, and it's all based on using hierarchical Bayesian models, and we develop all kinds of models. Risk models for invasive species, coupled models of physiology and demography, integrated models of fieldwork, and of course, forecasting models about what we may see. And with respect to classes, together with Chris Dick, I teach Woody Plant. This is a classic. I don't need to describe it. This is the ultimate field class. I also teach forest ecology and management, also a field class with a management component on it. And then for those who like data and analysis on that data, we have this third course. Thank you.